Hey everyone, it's Nathan with Crown and Caliber, and today you have the pleasure of not staring at my face. Today we actually have two guests. We have Charlie and Travis, two of our watchmakers, and you've actually seen Charlie before in some of our previous videos, and today they are going to be talking about all things timing machines. They're going to be talking about the history of timing machines, the progression over the decades and what has changed, what they do now, and basically what they do in watchmaking. How are they beneficial? How do they actually time the watch? And it's going to get pretty dense and pretty granular, but it is really good information. So here's Charlie and Travis.
Hello, welcome to Crown and Caliber. These are our timing machines. Indicate time. Or look off camera to Nate.
Oh, should I use my actual title here?
Action. I'm Travis Hines. I'm the head watchmaker here at Crown and Caliber.
And I'm Charlie Emsley. I'm one of the watchmakers here at Crown and Caliber as well. And in front of us, we have a massive pile of a variety of timekeeping machines. These are all machines that we use to measure the instantaneous rate of watches at Crown and Caliber.
Well,
some of them,
we don't use some of these machines.
Some of these are very outdated, and some are brand spanking new, cutting edge.
All of these machines do the same thing, just in slightly different ways as technology has improved. But what it's doing is it's listening to the ticking of a watch, and each time it ticks, it does calculations based on the time between each tick and everything else. And you can see on some of these machines we have little knobs where you set the lift angle, you set the frequency of the watch, and all of that information combined can give you basically your estimate of here's the rate of the watch per day, and here is the amount of amplitude that it has each time it's going.
In that position.
In that position.
The machines advanced as we got to more advanced technologies and the introduction of computerized microphones and recording equipment. We started gaining the ability to really further diagnose problems and really improve on accuracy. So while this machine can only tell you the rate, the beat, and the amplitude, later machines we can actually get a visual of the noise of the escapement. These have an oscilloscope function in them which lets us visually see how the escapement is running.
Whereas before, when you're using this, you had another piece of equipment that was the oscilloscope itself.
Right, which I
and
don't
so
have.
you would use that. So the modern technology is such that it's doing the work of three different machines essentially, because it's giving you rate, it's giving you amplitude, and it's giving you that oscilloscope functionality.
Rate is generally the term used to say my watch is gaining number of seconds per day, or losing. Amplitude is a measure in degrees of a circle how far the balance wheel rotates when it's struck by the pallet fork. So it's from its dead point to its most extreme is the degrees of amplitude. So when you say a watch has 270 degrees or 300 degrees, it's going from that dead point around a circle 270 or 300 degrees. 200 degrees, it's only going a little bit. You want it to go that further distance because you get more stable timekeeping when you're at higher amplitudes. There is an upper limit. Obviously, you can't go 360 degrees. Then you encounter a problem where the watch starts running too fast because it receives a second impact from the pallet fork. It's called rebanking. These machines can let us see it, even though you can usually hear it visually. You can hear it visually on this machine. Beat is the symmetry of the escapement on the entry side and the exit side. That relationship, basically you split it in half, the incoming tooth and the outgoing tooth. We measure the time it takes between that action to occur.
And the symmetry is important because if you're getting a lot of impulse on one side and not as much on the other side, then what tends to happen is the overall amplitude starts to drop for the watch because it has to work harder on one side, and then as that balance wheel comes back, it has to overcome that extra energy from the side that's getting too much.
Yep.
All of these machines operate on sound, and if the sound is off, then there's, in a lot of instances, even the newer machines, it will give you no reading. You will just get, it'll say out of range, or it'll give you an amplitude error, or it just will sit there and try to read it and not do anything. So in those instances, it helps to have a speaker because we can just hear it.
Yeah.
And sometimes you can hear a sound and say, wow, that's so out of beat, the machine can't even detect it. And so you go in there and you get that sound and you listen to it and you get it, a little more accurate, and then suddenly the machine picks it up and says, oh, hey, yeah. You're out of beat by 1.7 milliseconds, and then you can adjust it from there. The biggest enemy that we face in watchmaking is dust and debris. And the more things that you have out on your benchtop is just the more spots for dust to collect. And so, essentially you go from this on your bench taking up space to that.
Yeah.
And it's,
I love it.
having a single microphone that has a cover that goes over it, that eliminates, all of this.
All these little nooks and crannies for dust and debris to hide. I can see it hanging out underneath this one.
A healthy watch, what these machines are doing is, as it listens to all of these sounds, it does different displays. This one had just a printout and it was, just stamped on a piece of paper, whereas some of the more modern stuff has these digital displays. But what it's telling us when we look at this information is it's telling us how the watch is running. And if the amplitude is good, if the beat is good, if the rate is good, and all of those things kind of combined really give us a picture of the health of the watch. If a watch, is running 200 degrees of amplitude, that's not a healthy watch. It's one that's showing signs that it's dry. It's showing signs that there might be some wear points in there. There might be debris. There could be a problem with the escapement. And that's, we use these as a kind of our preliminary check. And based on that information, then we can use the more dedicated features of our advanced equipment to diagnose some of those more difficult things to find, like you were saying with the escapement and the oscilloscope.
So the B200 is the earliest of the machines we have on the table here. It's all mechanical in here. It uses a rotating drum that has a sort of spiral ridge on it. And that drum rotates at a speed that matches what the machine is told the watch is. So it doesn't have any automatic detection of the rate like the newer machines will have. You have to know it and input it manually. The machine below it, the Gradoscope, is purely for giving us a reading on amplitude. It can only give us a reading on amplitude. And this particular model uses a LED lights, so you can actually see where the amplitude is based upon that. An evolution of that is this machine. And I do not know which one is older off the top of my head. But this machine also only gives amplitude. It's a similar situation, but it uses a dial and needle instead.
Now, all three of these are just snapshots, right?
Right.
Like, this is not taking an average or anything like that. That's exactly in that second, that's how that watch is running.
If you want the average, you gotta write down. You let this print out you count it out for 30 seconds, 45 seconds, whatever you need to do. Then you can turn it on. The tape will start extruding. You write down your result, let it run for a little bit. You write down your result. You go to the next position. You pause the machine. This is, of course, to save paper. Move the watch into its new position, typically a pendant position. Turn it on, or let it watch run for a few seconds to stabilize. Turn this back on, let it run, write down the results, and you do that. So your timing can take 5, 10, 15 minutes if you're just trying to get a final reading. From there, you go up to the Expert 3. Expert 3 is an all-digital package. All its functions are a sum of the B200 and its partner machine. So you have all this stuff condensed into this one machine and its microphone. In addition to a few other options, you can select more advanced watches. You can start doing coaxial watches on some machines now. So some machines can't do that. So you can't get a reading on many Omega watches. The machine doesn't know how to interpret the data. The noises inside the coaxial escapement are different than the noises inside the Swiss lever escape. So you have the Expert 3, which does have the ability to listen to a coaxial escapement and give us a result. In addition to, it has a speaker function, it has the similar display layout. It's the long screen actually does mimic the original paper tape, which I think is pretty cool. And it's only been evolutions from there. And another thing this machine has is it can be calibrated. So unlike this machine, which cannot easily be calibrated to my knowledge, this machine has the electronics and smarts inside with the integrated circuit to receive a calibration signal from the machine, so you can make sure that it is accurate. Its master clock that it's comparing works.
The thing with this too, you're talking about the calibration, is you have to routinely calibrate it. You can't just buy one and then you use it for 20 years and it's perfectly fine. I've seen over time just deviances build in these machines where suddenly, you take it from one machine to another and they're identical except one's been calibrated and the other hasn't. And that's the difference between, 20 degrees of amplitude and, 5-10 seconds a day in a position.
Yeah.
The timing machines, like with anything, you have to maintain it. You wouldn't drive your car for 100,000 miles without an oil change. Why would you, have your watch timer do the same thing, essentially?
Right. These are fairly obsolete by today's standard. They've really been eclipsed by the newer machines that are, one, more affordable and have greater versatility, greater diagnostic abilities, and are much more condensed.
One of the features that this has that I really enjoy that the newer iterations that we use here don't is the speaker function.
Oh yeah.
It's all well and good to see something visually, but I like to hear the sound at times, so that's why we still have these around here in the office, and we make sure that anytime we need them, they're available. And it's still a very valuable tool. And kind of going from this, we'll talk about this for a moment. Looks very similar.
All these machines have one thing in common, except for one. They're all from Switzerland.
Yes.
Except for one.
This machine is, what is the name?
They call it the Time Grapher.
The Time Grapher?
It's got various brands that have added their name to the front of it, but it's generally just known as a Time Grapher.
It does all the same stuff that this does. The Time Grapher listens to the sounds. It gives you a nice little display. Doesn't have the same level of support that the Expert 3 does, or any of the Witchy products. It also doesn't quite have the same accuracy. You're also, with the Swiss-made timing equipment that we use here, you're really paying for quality. And this machine, while it is going to be great if you just want a quick check, this should not be a gold standard for how your watch is running. This is definitely for a quick, hey, it looks like it's losing some time. Oh no, it's, plus 7 seconds, great. It's not for any type of chronometer work.
No, we don't use it in our facility. But for hobbyists, maybe people who are interested in getting into the industry or have a large collection and want to just have something to show to their friends and see how things are performing, can use that machine, but they have to take the results with a grain of salt.
The other thing with this too is because of its price point and it's so readily available that people pick them up and then they're not using them correctly. And so if you don't know the lift angle, which is that degrees that is the escapement touching the balance, you can get a wrong reading on this. You can get a wrong reading on this. You can get a wrong reading on this.
Yeah, if you input the wrong information, you're going to get the wrong information out. And the lift angle is an important piece of information to know about the watch because it dictates how the calculation is performed to give you that amplitude reading. If you enter in a lift angle that is completely wrong, you will get a completely wrong degree of amplitude.
That's all to say that you can't just go out on the internet and say, what's the lift angle for a 7750? Because you're going to get 6-7 different results, depending. You really have to know a lot about your watch, and you really have to know a lot about your watch and that manufacturer.
Yeah.
Otherwise, you could be skewing your results.
Yep. Now, the machines have sort of picked a common lift angle of 52 degrees. That's sort of most watches out there are going to be about this lift angle, about this number of degrees. So a lot of these machines, when you turn them on, will just default to 52. But a lot of manufacturers nowadays, especially with various brands, have said, hey, we've found that at these various lift angles, our watches actually perform better.
So kind of moving on from this generation, we can come over here to the Witchy X1. This machine is what we are using here today for all of our timing. It is top of the line in terms of accuracy. It connects to the internet, which is something that none of these other machines do. It allows us to sync to a time standard. We have actually had updates where it has calibrated itself. We plugged it in and it connects to a server and says, hey, here's where I'm at. What are you saying? And then it just adjusts itself. And we can go into the settings and say, oh yeah, right here, like it's made an adjustment. Again, the X1 has got all of, this other stuff kind of built in. It has an oscilloscope. It can give you a polar reading. It can give you an average, over time, which is something that the older machines couldn't do.
Without using a couple meters of tape.
And this microphone here actually is automatic. So what it does is you put the watch on there and you have a program in that says, I want to test these positions. I want you to rest here for this amount of time for this amount of time, and then go to the next position. And you put your watch on there, you hit the button to go, and it will run on its own.
Yep.
And it's really very beneficial for us here when we're going through as many watches as we are. We don't have to sit there and babysit it like you do on these older ones where you have to, okay, now I want to do dial down. Okay, well, now it's dialed down. And then you're waiting on here, and okay, now I want to do crown down. So you got to turn it, and this does all of that automatically. Towards the end of 2018, Witchy came out with the Chronomaster. You can notice that there's some things missing from this. It's a microphone. What is that? Well, it's actually quite cool because it's software on your computer.
They're in the computer? In the computer.
They have taken the next kind of step, basically.
It's a logical step, really. It really makes a lot of sense.
And they took the X1 and took the programming and made it so you can load it right onto your computer. It plugs in with just a standard USB, and it does all the same stuff that this does, which is surprising to me because, when we got these machines back in 2014, this was science fiction to me. Like, whoa, this is so cool! It does all this stuff. But the Chronomaster now does it on your computer, and it makes it real easy because now, if I want to time something and I'm go out in the field somewhere, say I'm at a show and somebody's like, hey, can you check my watch? I can just open my computer, plug that in. I have all the same features that this has, but in a much more portable
Oh, much easier. Of course, it doesn't have the automatic microphone like this does. However, because of the software which has allowed you to connect this to your computer as well, because it is also still just a USB interface, you can get both these connected to the same computer at once. It's great. You can be working on one watch and have the other watch testing.
I mean, you could have two, really.
Or if you want to be fancy.
I mean, I like to be fancy. It's just great because it's like any other piece of software at that point. You're getting updates. If there's issues, you can reach out for technical support. This machine here, if I start to have an issue, I have to send it to an authorized center to get it diagnosed and repaired.
Yeah, you're looking for maybe weeks of being down without it.
Yeah, whereas, I can load that software on another computer if my computer crashes, and I'm good to go. Like, I just plug that into the new computer.
So the machines have gone from large clunkers that take up a huge amount of desk space, such as this. They've gotten smaller, they've gotten more accurate, they've gotten easier for us as watchmakers to use and deploy. The accuracy is phenomenal, but they're continuously getting better. They're continuously making these improvements. And you know as well as I do that the latest machine that is out there for timing uses lasers to measure the amplitude. And I would love to get one, but they are hideously expensive.
Yeah, well, once upon a time, the X1 here was a $12,000 piece of equipment, and now you can pick one up for a cool 8 Gs. It's relatively cheap.
Slowly coming down in price. So we've got this great stuff, these great tools, this great equipment we can use here in the facility. But if you put in the wrong information, or if you don't know how to use it, it's not going to give you good information back out. As the saying goes, garbage in, garbage out.
So what you're saying, Charlie, is you have to know how to use the equipment in order to get a result that actually is valid.
And on top of that, you actually need to know how to interpret the results.
Well, awesome, guys. Well, we hope this was super informative. If you have any questions, do not hesitate to ask them in the comments below. We can definitely relay any of these to Charlie and Travis. And as always, guys, thanks for watching.